when you study exponents, you learn what it means to square a number. For example, when you write a squared, what you mean is to take the a and multiply it by itself. When you take a number and you multiply it by itself, what you generate is a perfect square. Now we can look at a list here of perfect squares, and we see that, for example, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, etc. Now, for the purposes of studying square roots, it is a good idea to have as many of these perfect squares memorized as possible, and to be able to tell when you encounter one. Alright, so now that we know, or we remember what a square is, what we need to think about is square roots. Now that's the symbol that you typically see used to refer to a square root. The symbol itself is called the radical sign. Anything you put underneath it, like a x in this case, is called a radicand. Now on this radical sign, you assume, even though you don't have to write it, there's a little 2. 2 meaning square root. If the root was something other than a square root, you'd have to write that value down. Like if it was a cube root, you'd have to write a 3. A fourth root, you'd have to write a 4, etc. Now, we just looked at a list of squares. We saw, for example, that 2 squared is 4. We saw that 3 squared is 9. We saw that 4 squared is 16, etc. Now, you should think of square rooting almost as if it's the opposite of squaring. For example, when you take the square root of 4, what you want to know is, what did I square to get a 4? And of course the answer is 2. When you take the square root of 9, you're asking, what did I square to get 9? And the answer is 3. If you take the square root of 25, of course what you want to know is, what do you square to get 25? And if you think about it, it's a 5. Now, you need to remember, though, how negatives behave when they're squared. If I take a negative 6 and square it, I'll get a positive 36 for my answer. So what does that say about the square root of 36? Is it going to be a negative 6? Well, actually, this square root symbol, when we write the notation in this form, that symbol is implying that we are looking for a principal square root, which means that even though there is more than one number that can be squared to give you a 36, when we ask the question using this notation, it's the positive 6 that we're looking for. So out of any square root, you're always going to get a positive result. So, there are lots of square roots you can take mentally. For example, square root of 81, you should be able to do mentally, because 81 is on that list of perfect squares, and we know that 9 is what you square to get 81, so that's your result. Also, certain fractions you can take the square root of mentally. For example, square root of 16 25ths, you can actually take the square root of 16, which is 4, put it over the square root of 25, which is 5, and easily evaluate that. Now, since squaring gets rid of negative signs, you can never take the square root of a negative number. But remember, it's not a negative number if the square root's on the outside. So if you write it in that form, what you're actually writing is the opposite of the square root of 100, which is a negative 10. Now, this doesn't mean that we took the square root of a number and we got a negative answer. When we took the square root, the answer was positive, but the negative sign out front turned the answer after the square root was taken into a negative. Now, as you can see, anytime you take the square root of a perfect square, you get a nice rational answer. If you try and take the square root of something that's not a perfect square, rational answers will result. For example, hit second function, hit the square button, the square root symbol comes up. If I was to put in, say, a 12, which of course isn't a perfect square, your answer is a long decimal with no repeating values. That's telling you that you have an irrational answer. If I take the square root of 169, since 169 was on that list of perfect squares, it gives me a nice rational answer. If I take the square root of 4 over 49, I'm going to look to see if we can turn that into a fraction, and it is. So the square root of perfect squares gives you a rational answer. The square root of something that isn't a perfect square is going to give you an irrational answer. And even if you try to ask the calculator to turn that into a fraction, of course it won't be able to, because that's what it means to be irrational. It can't be turned into a fraction. Now beyond this, let's look at what happens when you try and take the square root of a negative number. If I take the square root of a negative 25, we're going to find out really quickly that that's not a real number. So when you take square roots, there's basically three different types of answers you can get. You can get rational answers when you take the square root of perfect squares. You will get irrational answers if you try and take the square root of a non-perfect square, and you'll get answers that aren't real numbers if you try and take the square root of a negative number. So those are several of the things that can happen with your square roots. And one more thing we need to look at is there is actually more than one way to write a square root. Let's look at a couple of examples. Alright? For example, if you had square root of 25, there's another way to write this. This is going to be a very convenient thing to be able to do in other sections. With the square root symbol, it can actually be replaced with a 1/2 power, which again is very convenient. One place I found it to be convenient is in computer programming. So 25 to the 1/2 power is going to be 5, because it's the same thing as the square root of 25. If I was to write square root of 144, that's the same thing as 144 to the 1/2 power, which should turn out to be 12, because that is the square root of 144, and we can verify this. Let's take 144, use the caret key for power, and don't forget to put the 1/2 power in parentheses, and we verify that that is in fact 12. Let's try another one. Let's take, let's say 100 to the power 1/2. Since the square root of 100 is 10, 100 to the 1/2 should be 10, and it is. And you can actually go through and take lots of other types of expressions and rewrite them this way. For example, if I had the square root of 5x, I could rewrite that as 5x, quantity to the 1/2 power. I could take a square root of a 17x squared y cubed and rewrite it as 17x squared y cubed to the 1/2 power. We'll do more later on as far as simplification is concerned, but for now it's good just to be able to write them in an alternate form.